Welcome everyone. Today, we'll discuss welding materials and the API 577 guidelines. These standards are essential for ensuring quality and safety in welding operations across industries. In this session, we'll cover the basics of welding materials and how API 577 provides guidance for inspection and metallurgy. Understanding these fundamentals is key to achieving reliable welds. Welding materials are critical components in the fabrication and maintenance of pressure vessels, piping systems, and structural assemblies. API 577 provides comprehensive guidelines for welding inspection and metallurgy, ensuring quality and safety in industrial applications. This section introduces the fundamental concepts of welding materials, including base metals, filler metals, and consumables. Understanding these materials is essential for achieving sound welds that meet mechanical and metallurgical requirements. API 577 emphasizes proper material selection, classification, and handling to prevent defects such as cracking, porosity, and incomplete fusion. The standard also outlines the importance of assigning P numbers, F numbers, and A numbers to facilitate consistency in welding procedure specifications or WPS and qualification records. By adhering to these guidelines, engineers and inspectors can ensure compliance with industry standards, reduce risks, and maintain structural integrity in critical systems. Next, let's look at P numbers. These group base metals with similar properties, simplifying welding procedure qualifications and ensuring compatibility. P numbers are a classification system used to group base metals with similar chemical compositions and mechanical properties. This system simplifies the qualification of welding procedures by reducing the number of tests required when welding similar materials. API 577 adopts the ASME boiler and pressure vessel code approach, where metals are assigned P numbers based on their characteristics such as carbon content, alloying elements, and tensile strength. For example, carbon steels typically fall under P number 1, while low alloy steels may be assigned P number 3 or 4. The grouping ensures that welders and inspectors can predict weld behavior and performance across materials within the same P number category. Proper identification of P numbers is crucial for developing WPS, qualifying welders, and ensuring compatibility between base metals and filler metals. Misclassification can lead to welding defects, compromised joint integrity, and non-compliance with regulatory standards. Now, let's move to F numbers, which classify filler metals based on usability and welding compatibility. F numbers classify filler metals based on their usability characteristics, such as electrode type, flux composition, and welding process compatibility. This system helps standardize welder performance qualifications by grouping filler metals with similar handling and operational properties. For instance, F number 4 typically includes low-hydrogen electrodes used in shielded metal arc welding or SMAW, while F number May 6 refer to stainless steel electrodes. By assigning F numbers, API 577 ensures that welders qualified with one filler metal can competently use others within the same group without additional testing. This approach reduces qualification costs and streamlines production while maintaining quality standards. Understanding F numbers also aids in selecting appropriate filler metals for specific applications, considering factors such as base metal composition, service conditions, and required mechanical properties. The American Welding Society or AWS classification system provides a standardized way to identify filler metals by composition and properties. The American Welding Society or AWS classification system provides a standardized method for identifying filler metals based on their chemical composition, mechanical properties, and intended application. Each classification includes a prefix and numerical code that conveys essential information. For example, an electrode labeled E7018 indicates an SMAW electrode with a tensile strength of 70 ksi and low hydrogen characteristics. AWS classifications cover a wide range of filler metals, including carbon steel, stainless steel, aluminum, and nickel alloys. This system ensures consistency in material selection, facilitates compliance with welding codes, and supports quality assurance processes. API 577 references AWS classifications to guide inspectors and engineers in verifying that the correct filler metals are used for specific welding procedures. Proper interpretation of these codes is vital for achieving desired weld properties and preventing failures in service. Finally, A numbers classify the chemical composition of the weld deposit itself, which is crucial for performance and corrosion resistance. The A number system identifies the chemical composition of weld metal deposited by a specific filler metal. Unlike P numbers and F numbers, which classify base and filler metals, A numbers focus on the weld deposit itself. This classification is essential for ensuring that the weld metal meets the required chemical and mechanical properties for the intended service. For example, an A number may specify the percentage of chromium, nickel, and molybdenum in a stainless steel weld deposit. API 577 emphasizes the importance of A numbers in welding procedure qualification records, PQR, as they confirm that the weld metal composition aligns with design requirements. Accurate determination of A numbers helps prevent issues such as corrosion, cracking, and reduce strength in welded joints. Inspectors and engineers must verify A numbers during procedure qualification and production welding to maintain compliance and reliability. Choosing the right filler metal is critical for weld quality and service performance. Selecting the appropriate filler metal is a critical step in achieving high-quality welds. The choice depends on several factors, including base metal composition, service conditions, mechanical property requirements, and welding process. API 577 provides guidance on matching filler metals to base metals using P numbers, F numbers, and AWS classifications. Considerations such as strength, ductility, toughness, and corrosion resistance must be evaluated to ensure compatibility and performance. For example, welding low-alloy steels in high-temperature service may require filler metals with enhanced creep resistance. Additionally, environmental factors such as exposure to corrosive media or cyclic loading influence filler metal selection. Engineers must also account for economic aspects, availability, and compliance with applicable codes. Proper selection minimizes the risk of weld defects, extends service life, and ensures structural integrity under operating conditions. Proper storage and handling of consumables is essential to maintain weld integrity. Proper storage and handling of welding consumables are essential to maintain their integrity and performance. Consumables such as electrodes, wires, and fluxes are sensitive to moisture, contamination, and temperature variations. API 577 recommends storing low-hydrogen electrodes in heated ovens to prevent moisture absorption, which can lead to hydrogen-induced cracking. Consumables should be kept in clean, dry environments and protected from oil, grease, and other contaminants. Handling practices include using gloves to avoid transferring moisture or dirt and ensuring that packaging remains sealed until use. Inspectors must verify that storage conditions comply with manufacturer specifications and industry standards. Failure to follow these practices can result in weld defects, reduced mechanical properties, and compromised safety. Implementing robust storage and handling procedures contributes to consistent weld quality and compliance with regulatory requirements. To conclude, proper classification, selection, and handling of welding materials are vital for compliance and safety. In summary, welding materials and their proper classification, selection, and handling are fundamental to achieving reliable and compliant welds. API 577 provides detailed guidance on P numbers, F numbers, A numbers, AWS classifications, filler metal selection, and consumable management. Adhering to these standards ensures structural integrity, safety, and performance in critical applications. For further details, refer to API 577, Welding Inspection and Metallurgy, which serves as an authoritative resource for engineers, inspectors, and welding professionals.